Hey everyone, today we're diving into one of the most important data structures in coding interviews trees, especially binary trees and how to traverse them. We'll break it down step by step and just simple concepts. What is a tree? A tree is a way to organize data in a hierarchy, like a family tree. The topmost item is called the root. Each elements are called node, and nodes can have children, and the last nodes are called leaves. It's not like a tree in nature, it's actually drawn upside down with the root at its top. A binary tree is a special kind of tree where each node can have at most two children, one on the left and one on the right. Binary trees are useful because they're simple yet powerful. They are a base for binary search trees, heaps, and more. You'll see them everywhere in interviews, and also recursion problems and system design. Traversal means visiting each node in a tree in a specific order. So there are three main ways to do this. So the first one is in order. In order includes visiting the left child first, then the root, and then the right. In binary search trees, this gives sorted orders. So we'll write it down. First, we'll visit the left, then the root, and then the right. So let's take an example. So first of all, we'll find the leftmost node. We'll start from the root and then we'll move on to the leftmost node, that is D. Then we'll move on to B. Then we'll move on to E. And after E, all the nodes on the left are over. So we'll move back to the root element. Then on the right hand side, we'll find the leftmost element, that is F. So from A, it jumps to F. And after completing F, it moves on to C. And then lastly, it moves on to G. And one is Postorder. Visits children first, then the root. It is useful for deletion and freeing the memory. So we write it as left, right, and root. So let's see an example. So first, we'll start with the leftmost element, that is D. Then we'll move on to the rightmost element, that is E. And then we'll go to B. So it is D, E, B. And then we'll move on to the right hand side completely. So here we start with the leftmost element, that is F. So again, we go for leftmost, then rightmost, and then the root. So that goes F, G, C. So this is covered and this is also covered. The only element left is A, that is the root element. The third one is preorder. It starts with the root, then goes to the left, then right. It's great for copying a tree. So we write it as root, left, and right. So let's see an example. So firstly, it will start with the root, that is A. Then it will move on to B, that is on the left hand side. Then it will move on to D and then E. So it goes from A, B, D, and then E. So after completing the left hand side, it moves on to the right hand side. So that is A, B, D, E, and then it goes A, C, F, and G. And there's also level order traversal where you go level by level, like reading a tree row by row. So, where are trees used in real life? They are used in file systems, HTML DOM structures, searching algorithms, auto-completed and spell checks, and AI decision making. Trees are everywhere, especially if you're into algorithms or interviews. To wrap it up, trees help you store data in a hierarchy. Binary trees allows up to two children, and traversals are a way to walk through the tree. If you found this video helpful, hit a like, subscribe, and comment. Thanks for watching and keep coding.